that up again. Okay, look up Weston for just a minute. Okay, Unit 1 was pretty much all, the tests you took were all AP problems. Test 2 was not. It was just practicing how to find derivatives. Test 3, we're back to all AP problems. And the good news is there aren't really very many new concepts you need to learn to succeed on Test 3. What we need to work on is reminding you of concepts you already have learned and learning to rely on those concepts. I'm still fighting to get all of you to get away from looking at a problem, like somebody did it today in A1. They looked at a problem like, I don't know what to do. Like you're only saying that because you're not thinking of rules that you have learned. You're looking at the problem and saying, I've never seen one like that before. I said, welcome to real life. Okay? So don't look at a problem and like if you've never seen one like that before, that's okay. Get used to it. Think of rules, think of flashcards that will remind you as to what to do. So Unit 3 is heavily on that idea of like just helping you learn how to solve unknown problems. There are a few new things that I need to teach you, but not really very many. It's mostly like just get really good at using all these different rules in different ways. So the flashcards were not really very helpful for Unit 2, but they are a necessity for Unit 3. The flashcard deck that you already have from Unit 1 should serve you very, very well. You may want to add a few to it. So that's why they're back on the desk. So, this assignment will not be due until Thursday. Okay? So today during class we're going to do some of these together. You're free to work on this as much as you want until next class, but we'll also do more work on it on Tuesday. Don't do the problems in order. Like if you see one you think you can do it, work it out, get an answer, compare it to each other. We're going to do this one like a quiz like we did before where you can talk to each other, you can ask for help. I haven't given you the answers. I want you to get used to that feeling of a test. Okay, so this will actually count as a quiz. That's why you have the Scantron. Question. We're going to work on this together a little bit. But I need your tests back, so put your Scantron inside your test and then hand me your test. You are welcome to look at your test as much as you like. You just have to do it in the room as always. So, you're welcome. Thank you. Okay, here we go. So the first one we're going to do together is number 1. Again, this isn't due until Thursday, but we'll start working on it today. We'll work on it again on Tuesday. You're welcome to come in and ask anything you want before and after school next week. I won't be here today after school, but okay. Second thing. Okay, your test score will be better if you have good notation. I guarantee it. So don't do most of these problems on this paper. There are some that can be done just on the paper. I'll kind of note that as we go along. But many of them you're going to have to do it in your notebook. Okay? I will continue to give extra credit for good notation, but it's going to be a really quick check. I'm just going to walk up, look. If I can look at a problem and read it, you get the points. Okay? If I can't read it, no points. It's really simple. It's got to be correct notation. Question? Awesome. Okay. Here we go. So as I read the problem, and again, what I'm trying to teach you is, if you read a problem and it reminds you of a previous problem, that's a good thing. But you have to be prepared on the AP test to read problems and have them not remind you of anything. And that's where you have to search for flashcards or rules to help you solve the problem. So I read this equation, and I immediately know what this is for. Like, as I see this, I'm immediately thinking of a couple of things. I'll pay if you can tell me what am I thinking of. Everybody? When I just stopped right here. As soon as I saw all this stuff, I thought of something. And you should be thinking of the same thing. Mikhail?
Finding the derivative of y prime.
So 2 points, no, stay with me, 2 points. I would definitely think of that once I got to here. But before I even got to there, I'm already thinking of something here. Drew?
Implicit differentiation. Is that what?
Oh, gotcha. 2 points for that as well. So you and Mikhail are kind of in the same place, that once I get to here, I'd be definitely thinking of implicit differentiation, for sure. 2 points. But before that, I'm thinking of something else.
Some kind of graph.
Some kind of graph. And I'm not really particular, so I just draw my favorite stuff. You know, that looks good. Okay. 2 points for Sarah. I'm still thinking of something else here. Hadley?
Well, it's equal to 2, not a variable.
2 points for that. I'm not really too concerned with that, to be honest, at this point. I'm just thinking of a general thing that I want you to remember every time you see an equation.
Something like factoring or something?
2 points for that as well, but I don't really want to factor this one. Okay, here's what I want you remembering. When you see an equation, you need to think list of x, y pairs. You see an equation, you think, I've got a list. This is the equation for finding the list. Okay, if you can't remember that, make a flashcard. That idea is going to come up in problem after problem after problem after problem throughout the test. When you see an equation, its primary purpose is to find the list of x, y pairs. And from the list, that's how you make the graph. Questions? Awesome. They ask us to find the derivative at x equal 1. Hands up, who can tell me what that means? What's it mean to find the derivative at x equal 1? I'll pay everybody for this one. What does it mean to find the derivative at x equal 1? Tristan?
You plug in 1 for x and then find the derivative.
Yeah, we've got this curve. This curve has a whole bunch of different tangent slopes. We're interested in a specific tangent slope. Wherever the coordinate x equal 1 happens to be, we want to know the tangent slope at that point. That's what this problem is asking us to figure out. Somebody knew that before he said it? Show me. Point and 2 for Tristan. Question? Okay, cool. So, somebody tell me the first thing we should do. Go.
Put it in the derivative form.
We got to find the derivative. So in my notebook, okay, you want the extra credit for your notebook? You got to tell me what you're doing. So you can't just launch into the problem. I got to know what you started with. So you should rewrite this. Now we take the derivative of both sides. I'm going to use the addition property, so the derivative of this is going to be 6x. Now I must use the product rule. Then the power rule. Derivative of 2 is 0. That's what you have to have in your notebook if you want the extra credit. Questions? Please.
Actually, never mind.
No worries, 2 points. Anybody else? Please, Weston.
So you have to write d over dx for like the 3x squared. You can just
points for that. Good question. Anyone else? If you write the dx dx, it's fine, but you don't have to. So.
Okay.
Awesome. So I'll keep going here. Question? Guys, can you know? Cool. Need to rearrange here. So I get 2x y prime plus 2y y prime. It's going to equal negative 6x minus 2y. Questions? Keep going. Factor out the y prime. Divide. Questions? Bothering anybody? Again, don't ever just mimic what I do. You have got to know the rules that I'm using to solve the problem. So, please.
Does it need simplified, or is it just because you don't need to?
Oh, awesome. 2 points for that. 2 points. Well said. Yeah, I knew I need the derivative formula, Maya, because the derivative formula is how I find the tangent slope at any point on the curve. I don't really care about the simplification. Yeah, I didn't even think of it, to be honest, because I knew it wasn't required. So, good question. Now what do I do? Hands up. Okay, everybody? You know it? Hands up. Sarah?
Plug in 1 for x.
So I need to find the tangent slope when x is 1. How many knew that? Point, 2 for Sarah. What's the problem I'm running into here? Avery?
You still have a y there.
Still need a y. How many knew that one? Point, 2 for Avery. So Weston, please.
Would you plug in x for the normal, for the, I don't know.
Just call it the curve is fine.
Curve?
Yeah,
Okay.
like I don't know what the better thing to call it. So I just refer to this as the curve, and this is our formula for finding the tangent slope of the curve.
Oh, okay.
I don't know if there's a better way to say it. They use that wording on the AP test frequently, so that works pretty well. Is that what you meant?
Yeah, that's what I meant.
Perfect.
So would you put the 1 in for the curve and find y through that and then plug that in the derivative?
Perfect. Perfect. Okay, pause at this point. 2 for Weston, 3, 4, mark them down. Okay, that's the big idea for Unit 3 and the AP test. Is I don't think you've ever seen a problem worded like this ever. It's brand new. But there really wasn't any new concepts to teach you. It's just trying to help you learn how to draw on concepts that you've already learned, just like Weston just did. Like you already knew that you can use this to find every xy pair of the curve. You knew that. You knew how to find this derivative, like Drew said, using implicit differentiation. You knew that this formula is how you find the tangent slope. It's just you learning to put them together. And warning, I can't give you an example of every possible problem the AP test will have. It is not possible. So don't try to solve problems by remembering problems. Solve problems by remembering flashcards. Okay? Questions? Okay, cool. So I'm going to come over here and box this off so I can tell that I'm not doing the same thing here. And we need to use the equation here now. So I take 3, plug in 1 for x. This is a habit that I picked up a while back that has made a huge difference in preventing mistakes. If you'll have the same habit, you also will prevent many errors. I'll pay if you can, well, that's kind of hard to see. Right here, whenever I take away a variable, I always replace the variable with a set of parentheses. If you'll do that, you will prevent errors, especially when they start throwing in negatives. So you take away a variable, put in a set of parentheses in place of the variable. Questions? Cool. So I start working on this. So this is 3 plus 2y plus y squared is equal to 2. Okay, reviewing again. So the flashcard memories that you have got to have with regards to this problem are, all right, they want the derivative at a point, so I need to find the derivative. That's one memory. When I go to find the derivative, I don't have the y value, so I've got to remember that I can use the equation for the curve to find the y value. Now you need to have memorized this. This is a quadratic. Okay, number y squared. You'll see them all the time on AP problems. Every time you see one, you must remember that the way we want to try and solve the quadratic first is by factoring. Okay, so that's got to be a flashcard memory. So I rearrange this to look like this.
Isn't that a 3 on the end?
So I move the 2.
Oh, okay.
No worries. So the proper way to solve a quadratic by factoring is we want to get the quadratic to equal 0. So we just grouped everything to the left. 2 points for Isaac. No? Oh, Elijah, sorry. 2 for Elijah and Isaac, so what the heck. Voices were similar enough, so maybe, I don't know. Say hello.
Hello.
Say hello. Yeah, you know. Say hello.
Hello?
Say hello.
Hello.
Yeah, definitely not similar. Okay. Questions? We'll do the voice game later in the year if you'd like. So it's like I turn my back and you all shift around and then I see if I can tell who you are, you know. So usually works out pretty good. Questions? Awesome, cool. Now you factor. So the point of interest is an x-coordinate of 1 and a y-coordinate of -1. Question?
How do you get the -1?
So solving an equation means find the value which makes the equation true. So I want this to be true. So if I choose y to equal -1, yeah, no, 2 points. Please, Ellen.
If there were different numbers, we just have 2 y values.
It is very possible to have a curve where you have 1x produces 2 y's. It's not a function, but it can happen. If they do that, they'll probably change the problem in some way to help you know how to deal with that. Yep, 2 points. You know. Okay, last step is to plug it all in. So, again, you want the extra credit for notation. I have to see this on your paper. I have to see this on your paper. And then finally, this one here. Y prime when x is 1 and y is -1 is going to equal and as the AP test is wont to do, they made something interesting happen. We end up with a slope, tangent slope that is number divided by 0. Okay, memorize this, make a flashcard if you need to. If the tangent slope is number divided by 0, the curve has a vertical tangent. If the tangent slope is some number divided by 0, then the curve has a vertical tangent.
Sorry, can you do it one time?
So if the tangent slope is some number divided by 0, then the curve will have a vertical tangent. Tangent slope is some number divided by 0, then the curve will have a vertical tangent. It's a little weird, Brendan, because the derivative actually has a vertical asymptote. Like this formula being number over 0 means this formula has a vertical asymptote, but it equates to a vertical tangent for the curve itself. So yeah, the correct answer on this one is undefined. There is no known slope at this point. So. All right, so this problem represents, I would say, let's see, first flashcard is I've got to recognize that with the curve, I can find all the xy pairs of the curve. That's one flashcard you're going to use repeatedly on all kinds of different AP problems. The second one is not really a flashcard. It's just remembering that derivative means find the derivative, we get a formula. That's more of a process. That was an entire unit. Okay, so we did that. Oh, I'd say a third flashcard is this idea of a quadratic. That pops up in lots of AP questions all over the place. And the fourth idea is vertical tangent. Please.
Are the quadratics in the AP test usually just going to be ones you can factor, or are we going to have ones we have to use in formula?
Good question. 2 points for Hadley. I've never seen a non-calculator AP question that involved a quadratic that I needed the quadratic formula. Usually they are factorable. I did see an equation where it couldn't be factored, but you could reason out what you needed without factoring. It's a little bit different, but you didn't need the quadratic formula. So I've never actually used the quadratic formula on the AP test. I have seen ones in the calculator section that you don't want to solve with factoring. You just want to use your calculator. Like you just graph this, graph 2, see where the intercepts are. Good question. Please.
Just one other question. When I was looking at it and we found the negative one using the quadratic formula, wasn't that for the original equation and not the derivative?
Perfect. So we said, okay, here's my formula for finding the tangent slope at any point on the curve. I need to find the specific tangent slope on the curve where x is 1.
Yeah, so we know x, but how do we know that the negative one goes there?
So we use this formula. We plug in the y, and then plug in the x and find the y. So this is all finding the xy pair on the curve itself. Then we took those numbers and said, hey, how do we find the tangent slope at that point? We put them into this.
Oh, okay. That makes
That
sense.
connect. 2 points. Okay, one last time I'll say it. You're not going to succeed on test 3 by memorizing this problem. You succeed by memorizing those 4 flashcards that I just pointed out and understanding what Rachel just said. Like that was a really good summary of the whole idea. So, yeah, please.
When you factor, like in this case, it will have to be +1 equal -1. What if the terms are different? Which one would you?
Gotcha. So if you ended up with like 2 different values for y, there would be some other clue in the problem indicating which one you should use. Or they would possibly have 2 answers for each one. I've seen that happen as well. So. Yeah. Like it'd say this, Sarah, it'd say 2 points. It'd say then the value of this at x equal 1 is, and it'd say, oh, -2 and 6. Like there'd be 2 answers. Does that make sense? Perfect. And like people who didn't understand what you're asking about would be like, what the heck? How come there's 2 answers for everything? You'd have to understand that that's possible and can't happen. So, you know. Awesome. Next one. So we won't do every problem. I'm just kind of going through the packet looking for things that are new. Go to number 2, please. Okay, no new concepts needed to solve number 2, but I do want to remind you of something. There's a fast way and a long way to solve this problem. If you happen to pick the long way, it's all right, it's not that long, but there is a shortcut that's very useful on this and other problems. So I'm showing you the shortcut, not for this problem. I'm showing you the shortcut for some other things, okay? Anybody know the shortcut? There we go. Hands up, okay, everybody. Who knows the shortcut on this one? Let's try Maddie.
So the natural log of e is equal to 1.
Oh, 2 points, but I don't want you to remember it in that way.
Okay.
That can cause a problem, okay? Because this really isn't the natural log of e raised to the 2x. It's e raised to the 2x natural log of that.
Okay.
So what you're thinking can cause mistakes, so don't remember it that way. Like natural log of e is 1, but don't remember it that way. 2 points. Let's go, Elijah.
Isn't that the down and front rule of powers of the log?
So Elijah's remembering this principle. I would get this on a flashcard and memorize it. The natural log of e to the a power is the same thing as a natural log of e. That's what Elijah's remembering, and that is correct. Weston?
You can just cross out natural log of e and just put 2x.
There you go. Natural log of e is 1. So the natural log of e to any exponent is really just the exponent. Yeah, no canceling. I took them off the board and everything. I thought I could trust you all.
Yeah, that was my beat.
It's all right. 2 points for Weston. Question. So memorize this. Okay? This isn't, I mean, it's not that important for this problem. You can solve this another way. It's really important for some future things. So get it memorized.
Wait, log of e is 1.
Natural log of e is equal to 1. So this derivative, so I started with this. This is equal to this. Oops, my bad. Because the natural log of e to the 2x is just 2x. Question. Please.
So on the top row where you just did ln of e to the power of a equals a to ln times e, does it need to be e in order for the a to be able to go in front of that?
So let me back up a step. 2 points for Weston. Are you talking about this one, number 1, or number 2?
Number 1.
Gotcha. Number 1 is true for any log.
Any log? Okay, I see. Okay.
You're good. So that's true for any log, doesn't matter the base. This one is specific for. There you go. Awesome. Okay. Oh, please. Hey.
You already used that one, and that equals just 2x. Like, how did you get rid of it? If you use like the little shortcuts you use, how do you get rid of the x?
So what I did was I said they're giving me this problem to begin with. You good there?
Yeah.
I memorized that the natural log of e to any exponent is just the exponent. So instead of finding the derivative of this, I'm finding the derivative of 2x. But I still have to find the derivative. The derivative of 2x is simply 2. That didn't help.
But on the shortcut, you're just bringing down the 2 down. Is that what you're doing?
I'm using this one. The natural log of e to any exponent is just the exponent. That gets me from here to here. Because this is the same as this. But they're asking me to find the derivative. So I still have to go one step further and find the derivative of 2x. That answer it? 2 points. Anybody else? Okay, I want to give Hayden some more points. Listen, mark down 4 more. Here's one. Put 5, 6. Seriously, look. The thing he did that is so important for this class is he stuck with it. Like I gave an answer and it wasn't enough to really click. He didn't fail and say, "Oh well, I'll figure it out later. He stuck with it. You have to do that, okay? I promise you, if you have things coming to mind and you're going, I don't get that, if you don't ask about it, it'll haunt you later. It'll get you on the test, guaranteed. Okay. Questions here? Okay, with regard to notation, I used a lot of notation so you understood what we were referring to, but if you solve this without any notation at all, it's fine. Okay? You can do that one completely in your head if you understand the rules. So you don't have to write anything on something like this. You could just, oh, that answer is 2, fill in your Scantron, good enough. So, question? Awesome, next one. Okay, number 3, based on our discussion today, you should need no help to solve number 3. You have all of the flashcards necessary to solve number 3. Unless someone's thinking of something like, wait a minute, I can answer questions if some questions coming to mind, but I really don't think you need any help to solve 3. No questions? Okay. Again, as you're working on this, you don't need to go in order. You can just do the ones you can do and then wait till Tuesday to get more help if you need. So, because we're going to talk more on Tuesday. Number 4, I do not think you need any help to solve number 4. Does anyone have any questions coming to mind with regard to 4? Cool. Number 5. Number 5 does have something that people forget. I believe there was a test question that looked almost exactly like this. At least there was one on one of the practice tests. You must have memorized that cosine squared of something really means this. For cosine cubed, this would be cubed. So make sure you have that memorized. Questions? So again, a lot of test 3 is not new concepts, right? Most of it isn't. There's very little that I have to kind of teach you that's brand new. It's mostly putting together things you already know in different ways. Okay, next page. The only thing I would remind you on number 6 is arc sine means the exact same thing as inverse sine. Arc sine and inverse sine are the same thing. Otherwise, nothing new that I need to teach you there. So. And again, the rules for this quiz are the same as they were on the other big packet quizzes we did last unit, the yellow and the blue, where you can talk to each other, you can get help, you can ask me questions, you can compare, whatever you want. But the more you do it like a test, the more it will help you with the test. So. I don't really think it helps to work together on things. I think it's better to work alone and then compare. So, nothing new that I need to teach you on 7 unless you're seeing something that's bothering you. Nothing new on 8 unless you're seeing something that I'm not seeing. If you do have a question pop to mind, go ahead and ask. So, 9 and 10. Anything there you see that's like, wait a minute, I don't understand this or that, or
number 9 is just the exact same thing as number 1, right?
yeah. In fact, if you look at it, 9 is identical to
3.
and nothing on that page. I think I heard someone say, yeah, 3 for sure. And really, it's identical. There is a big difference between. Well, let's see how many in the room can figure this out. This is a good question. Extra credit for this. Look at number 1. Look at number 3. Look at number, what is it, 9?
Yeah.
There's really only one difference between those 3 problems. Does anybody know the difference? Okay, for everybody to know. There's really only one difference between those 3 problems. Jane?
The number 1 has a y in the answer or in the equation for the derivative.
So number 1, when we found the equation for the derivative, we ended up with a y along with the x, and that's why we had to do the extra work here. On problem number 3 and problem number 9, that's not going to happen. You will only need the x value. Otherwise, they are the same. 2 points for James and Ashley. Anybody else? Cool. Let's see, 10, I didn't hear any questions. Next one. Again, try to do this without your notes. The sooner you get away from your notes, the better prepared you will be for the test. The longer you cling to the notes, the harder the test will be. So, let's look at 11 for a minute. We talked about velocity and position. Lost almost completely. Wow. Okay, read number 11, please. Raise your hand when you have an idea of what you should do. I'm going to copy and paste this so I can get some notes. Who has an idea of what we should do? There we go. Nothing new to teach you here, just things to remember. There's nothing new to be taught, just things to be remembered. Let's try Ellie.
There's acceleration.
Oh, sorry.
Oh.
My bad. No, go ahead, Ellie.
Okay.
You're good.
Wouldn't you find the second derivative?
So they give us the formula for position. So that's this. S of t equals. If you want extra credit, you got to write down S of t in your notebook. If I don't see S of t, I don't know where you're starting. Acceleration is the second derivative of position. So we find S prime. That's going to give us velocity. I'll let you do that on your own. Then you find S double prime. That's going to give you acceleration. How many knew she was going to say that before she said it? Show me. Point 2 for Ellen. Questions? Cool. Next one. Do we have any questions on 12? Do we have any questions on 13? These are all old AP problems now, so we're switching back to just practicing AP stuff. Okay, 14. Oh yeah, please.
The subtraction, like, can you do the subtraction and addition rule?
Good question, Hadley. 2 points for Hadley. Yes, addition and subtraction are essentially the same thing. So I would simply find the derivative of this minus the derivative of this plus the derivative of this. What do you have? Cool. 14. There's nothing new to be taught here. This is just reviewing some stuff from term 1. I'm going to let you try this one alone first. You don't learn very much if you just discuss it right away. You learn far better if you kind of battle with it a little bit. Don't spend too much time, but work on this a little bit. Feel free to discuss with other people. See if you can figure out the answer to this one. We may discuss that on Tuesday. Anyone have a question on 15? Cool. 16 has some new ideas.
Wait, sorry, 15 is just gives us the point to have to do that stuff to figure the points out. It saves
Perfect.
the one.
Perfect, Brandon, perfect. Look, so it's identical to 1,
But
Except that,
gives me.
you don't have to find this. So they already gave you the X and the Y. Perfect, it's the only difference. Anybody else, questions there? Cool?
Wait, I have a
Oh, go
question.
ahead.
On 16, wasn't it mean when it says an equation of the line normal to the graph?
Yeah, that one is new, so let's talk about this for a minute. Let me get a copy and paste here, two for Mikkel. So let me copy and paste this one. Hold on a second. Give me 1 second, I gotta fix something here. Hold on a second. Stop.